number 9, Quantitative Chemistry, Standard Solutions and Titrations. All right, so what we're going to do first for Part A and Part B, we are going to prepare some standard solutions of potassium ferrocyanide and zinc sulfate. So in the pre-lab, you were supposed to calculate some masses of each solid that you would weigh out to create a certain concentration of a particular solution, or create that volume of a particular solution. So we're going to use those masses and create those two solutions. So in front of you, I have already weighed out those masses. So you calculated an approximate mass, but I can't get exactly. You should have calculated about 2.6 grams. I'm not going to stand there and weigh exactly 2.600 grams to get exactly that concentration. So I did take a mass that was roughly 2.6 grams. And then you can calculate the actual exact concentration from this mass and from the volume of our volumetric glassware. So our mass of the potassium ferrocyanide exactly is 2.6893 grams, and we are going to dilute that into a piece of what's called volumetric glassware. So volumetric glassware will measure exactly 250.00 milliliters. There are a couple grades of volumetric glassware. There's A and B. We have A grade glassware, so we can have 2 decimal points in our significant figures and calculations. So this is going to be the container that I'm going to use for my stock solutions. So this first one I've labeled nicely with the K4FeCN6. And I don't know, let's see if you can see the little guy right here. There's a tiny little really faint line etched into the volumetric glassware. So that tells you the line to which you should dilute your solution to have exactly that volume of solution, to have exactly 250 milliliters, 250.00 milliliters of this solution. So let's get started with the process. So here is the potassium ferrocyanide trihydrate. It's kind of a pretty little yellow crystal. So what I'm going to do, actually I forgot to grab something. So I've got both of my masses weighed out for my potassium ferrocyanide and my zinc sulfate dihydrate. I forgot to grab something. So I'm going to pause it and go get what I need. Okay, I'm back. I went and grabbed the thing I needed. Okay, so we've got our volumetric glassware, our volumetric flask. I've already put a little bit of water in the bottom just to make sure it would pour out of my beaker nicely. So I've got my weighed out mass of the potassium ferrocyanide trihydrate. Okay, so I'm going to go ahead and get that into my glassware. I'm going to use, you could try a funnel, probably wouldn't be a terrible idea. I'm going to just use my weigh paper. I'm going to wrap it up like a little burrito. Yeah, it's not wrapping the way I want it to. There we go. Go ahead and get all of that in there. Okay. All right, so we are being quantitative, so we do want to be careful with our numbers and our procedures and keep track of everything. Of course, we will have a little bit of loss. We won't have too much. All right, so now I'm creating the solution, and I'm going to add deionized water to it. I'm going to go ahead and squirt this DI water so it rinses everything down the neck of this. So one thing you do want to be very careful of is you don't want to go across that mark. You don't want to fill this up past the mark that tells you the exact volume of the solution. So once you go past that, you don't know the volume of the solution, and you will no longer be able to get that perfect volume. You have to start over. All right, so now that I've got some water in, I'm going to swirl my solid to dissolve it, and then I'll continue to add water. And then when I get close to this mark here, which is super hard to see on the camera, once I get close to this mark here, I'm going to take it very, very slowly. So just the bottom of my meniscus is the one at that line, indicating that I have exactly 250.00 milliliters of solution. I've labeled it so I know which solution is which, because we're going to be working with two different solutions here. I don't know if you can see this. You can see this right here. I've got my burette set up for the next couple of steps, and I've labeled my waste container so I don't have to keep going back and forth each time to the waste container. I'm just going to put it all in there and then take it to the hood at the end of the lab and properly dispose of my waste. All right, so my solute is starting to dissolve into my solution. Most of it's in there. I'm going to add a little bit more water, deionized water or distilled water. Swirl it again. Like I said, you always want to take it easy. You don't want to go past your marking on the volumetric glassware. You're going to end up unhappy and redoing it. All right. Quite a bit of water in there. I'm going to swirl it together. I still see a few crystals on the bottom, so I'm going to swirl it till they completely dissolve into the solution. Come on, little guys. All right. Keep swirling, swirling, swirling. I need some more DI water. I'm going to put some more in this container into my beaker. All right, I'm going to very carefully continue to add my DI water until I start to get close to the neck. And then I'm going to start to add it dropwise. Really close to the end, so now I'm going to get a pipette and I'm going to squirt water in dropwise at the end because I do not want to go past that and start over. That does not sound like fun for me this evening. So I'm going to come down here level so I can see the meniscus and squirt it in, taking it easier. Almost there. Quantitative chemistry is definitely about a lot of patience and being very particular and precise with your measurements. Very precise and accurate. Drop, drop, drop. One more. One more. There we go. Nailed it. Looks good. All right, so I'm going to put my stopper in, and I can go ahead and mix my solution up, making sure my solution is thoroughly mixed. And that is my first solution of my potassium ferrocyanate solution. All right, so next up, I'm going to make my approximately 0.50 molar zinc sulfate solution. Again, we calculated approximately how much mass we would need to make that solution, so I've weighed out exactly 3.6529 grams using the analytical balance, giving us lots of significant figures. And I'm going to use the same kind of glassware that I've labeled so I don't get the two mixed up later on. No, one is yellow. It's white or clear and colorless. I'm going to go ahead and wrap my whey paper up, use it a little bit like a funnel. Clean my tush. Okay. Or we could actually just use a funnel, might not be the worst idea. I've got like a clump. There we go. Got it all in there. Do the same thing, adding DI water and then swirling to dissolve, and then topping off my solution. So you have the solid, you add some water, you swirl to dissolve, and then you top off the solution. Alright, that looks pretty good. I don't see any more crystals floating around in there. So let's add a little bit more water. So on this one, on this piece of glassware, we have this little guy that helps you see. This little red mark, it'll help you see your line. So on this piece of glassware, my line was all the way up here. So on this glassware, my line is all the way down here, and that's specific to each particular piece of glassware because they are calibrated to be exactly that volume. So always make sure you pay attention to where that line is and you don't overshoot it, because the struggle is real, my friends. The struggle is real when you have to start over. All right. Slowly. Okay. All right. Let's fill her up. That's a couple of milliliters. Sometimes people will do it straight from the DI bottle and try to add it dropwise. But I've found that can be very easily a fatal flaw in getting your solution to be exactly where you want it. I would not recommend it using this squirty bottle to do that. It's not as easily controlled. But if you like doing things twice, you do you. Okay, there are my two solutions for part A and part B. We have the same computer controls, we just have slightly different masses. Those masses will be recorded in Google Sheet of data for you. Let's look at part C now. Yep, and I told you, let's see, this tells you to consider your atomic weights and your volumes and masses that we took. How many significant figures can you claim? So you should be able to figure that out. All right, part C. We're going to prepare our burette for titration. I'm going to actually move the camera just a little bit so you can see the full burette because you can't really see it. So, BRB. All right, my friends, here we go. I've reoriented the camera. Now you can see a full picture of the burette. So our burette is this piece of glass right here, and it holds up to 50 milliliters, and it has markings on it. It will give us lots of nice significant figures. So we have markings to every 10th of a milliliter, so we can estimate to the 100th place. That's where our significant figures will come from. So this one is marked where this volume up here is 0 milliliters, and then our volume down to 50 milliliters at the bottom. So down here we have a stopcock that opens and closes to allow your solution, your titrant, to go through the burette. So we're going to do the titrant and create a change in color in our solution. So when the stopcock here, if you can see it, it's a little bit on the back, is perpendicular to the burette, it is closed. When it is parallel with the piece of glassware, then it is open and will allow your titrant to flow down to your solution. Right now I just have my waste container to catch the waste as we prepare the burette full of zinc sulfate. So we're going to rinse the burette with 3 to 5 milliliters of the zinc sulfate solution that we have prepared. So we're going to put some of the solution in. We're going to rinse it around and swirl it around to rinse out whatever is in there. And then we're going to also allow it to flow through the stopcock and rinse out anything that could be in there, any plain water. And then we're going to replace and fill this tip of our burette with just our zinc sulfate solution before we go ahead and fill it all the way up with our zinc sulfate for our actual titrations. So I'm going to close it. I don't want my solution to run through just yet. Okay, I have placed a funnel up in the top to help me make sure I don't pour my solution all over the place. Oh, did I forget to show you? Here, sorry, I think I did. Little white crystals. Little white crystals for our zinc sulfate. Have to hydrate. Okay. Remove my glass stopper. Pour it in my solution. Just a little bit, just a few milliliters. I don't want to waste it. In case I screw up on my titrations, I want to have plenty of my solution. Okay. So now I'm going to swirl it. I just got this perfect. Loosen my clamp. Set my burette free. And go ahead and allow the solution to run out here without pouring it out the end of my burette. Swirl it throughout the entire inside of the burette. Okay. just rinsing out the whole thing. Back in my clamp. And run it through. Get rid of that. Let that drip out. Do one more small rinse. My zinc sulfate. Swirling the solution inside of my burette to rinse out any other contaminants that could possibly be in there. So only my solution of interest is in my burette. Okay, I'm going to run that through. Quantitative chemistry might not be the most exciting chemistry to watch, but you can only get some good information from it. Okay, so now that I've done my rinses, I'm going to go ahead and fill my burette with my zinc sulfate solution and note my starting point and record that in the data for you. And when we start with all right, so now I'm going to fill my burette. Doesn't matter exactly to where, as long as I note exactly where. I'll spread my funnel. As long as I know exactly where I have filled it to. Make sure your stopcock is closed. I've had students fill their burette and just run all their solution right out. Okay, so I actually overshot the top. I'm past the 0 mark, so I don't know exactly what my starting point is, but that's okay, because I've got a little air bubble in the bottom there, and I want to run that through anyway, so I'm going to let this solution come down past that 0 point, so I know exactly where my starting point is, and I get the air bubble out as well. There we go. Air bubble's gone, and I've got a starting point of my zinc sulfate solution. All right, that is it for part C. We've filled our burette. Let's see if I can take a reading. I'll do it when it comes to that one. Let's not skip steps, huh? Let's skip in order that the report goes in, or your handout goes in. Okay, so part D, titrating the potassium ferrocyanide with our zinc sulfate solution. Okay, it's more volumetric glassware. We're going to pipette 25 milliliters of the approximately 0.025 molar potassium ferrocyanide into 250 milliliter Erlenmeyer flask, and add about 5 milliliters of 3 molar sulfuric acid and 3 drops of freshly prepared potassium ferric cyanide solution and our diphenylamine indicator. Okay, let's see. So our pipette, again, is another piece of volumetric glassware designed to deliver the exact volume. So this guy is designed to deliver exactly 25.00 milliliters of your intended solution. So we're going to use suction to draw the solution up with our bulb, little squeezy bulb, super high tech, and we are going to suck the solution up until our meniscus is exactly at the line that indicates that 25.00 milliliters, which takes a lot of practice to be good at. It's such a pain in the butt. So let me move the camera again so you can see what I'm doing a little bit more. Okay, here we go. Part D, titrating. So we're going to go ahead and pipette our 25 milliliter aliquots of our potassium ferrocyanide. Cyanide. I keep saying that funny. Cyanide. So I'm going to go ahead and we're going to practice pipetting, and we need to do this. We're going to run through this procedure 3 times. I've got 3 about 250 milliliter Erlenmeyer flasks. That's these guys here. And I'm going to go ahead and do all 3 portions of my pipetting. Because it's a pain in the butt, I want to get it over with. Okay, so we've got our known solution of the potassium ferrocyanide. I'm going to use my pipette bulb. I'm going to push the air out, and then I'm going to put it on here, and I'm going to place this in the solution. I'm just demonstrating right now, and that will suck my solution up from my glassware. You do want to be careful. You don't want to grind the tip of this into this piece of glassware, because you could break the tip, and it's expensive glassware. And so another thing to be careful of when you are sucking the solution up into your pipette, because you want to get it to this line, you're going to go just past that line, but be careful, because when your solution goes past this fat part of the bulb and gets to this skinny part here, it kind of is like, whoo, all of a sudden it goes up really fast. So you have to kind of be prepared to let it go. And then you put your finger on top and slowly release your finger until the solution comes back down. So your meniscus is right at the mark line, telling you have exactly 25.00 milliliters of your solution to deliver to your sample container. All right, so squeeze out my bulb. Go ahead and pull my solution up in. That's going to be another squeeze. All right, it's getting close. It's going to go fast when it hits that spot. All right. So there we go. I've gone past. My mark is right here. My solution's right here. You guys can see that or not. And I'm going to go ahead and slowly let my solution out until my meniscus reaches that line. And I have exactly 25.00 milliliters of my solution. Go ahead and put it into my Erlenmeyer. So I've got sample 1 almost ready to go. I've got to add a couple more things to each one. I'll do that as I go. But I want to get the pain in the butt part out of the way first. Okay, so that is our first one. Other 2 samples over here. Let's practice this again. And it does take practice. Drawing my solution up. Oops, there we go. All right, again, my line is right about here. My solution's up to there. Let's go ahead and slowly let it out. I have exactly 25 milliliters. Release the pressure. Let it draw out into my sample container. Can't see what I'm doing. There we go. Sorry, I'm not the best cameraman. Don't do that. Don't drop the pipette. Oh, I let it down too far, so I'm going to have to sag it back up a little bit. All right, nailed it. All right, there we go. And there is a tiny little bit of solution left in the tip, and that is supposed to happen. That is the way the vinyl is designed. There's my known. Get that out of my way so I don't knock it over, spill, and make messes. Get my waste container out of my way here. I don't need that there anymore to catch anything. So I'm going to go ahead and add the other ingredients that I need for my indicator. So what we're going to do is we're going to add this known concentration of zinc sulfate to this known concentration of the potassium ferrocyanide with cyanide with an indicator, and we're going to see a color change happen. And that's when we're going to know we're at the end point of our particular reaction. We're at the end point of the reaction, and then we have an equivalence point, right? And then we can use that equivalence point to count the number of moles, to figure out the mole ratio, and choose which one of these equations for the grading of the lab is what's actually happening, what the actual mole ratios are for this particular reaction. And then once you find the actual reaction, then you're going to find the concentration of an unknown in part E. Okay, so let's go ahead. I've done my pipetting for 3 solutions. I'm going to add about 5 milliliters of 3 molar sulfuric acid. So I have my 3 molar sulfuric acid. Let me get here will work. We get about 5 milliliters. So it doesn't need to be perfect. All right, pretty good. All right, so there's about 5 milliliters of 3 molar sulfuric acid. There. Go ahead and add that. Use that again. 3 drops of the freshly prepared potassium ferric cyanide right here. So I'm going to go ahead and add 3 drops of that. 1, 2, 3. I'm not on camera at all, am I? Son of a ding dong. There we go. Make sure you catch the next one. How about that? So that potassium ferric cyanide was a little bit more yellow in color, so it made my solution yellow after adding my acid, which was also clear and colorless. So I've got a slightly yellow solution. Now I'm going to add my indicator, so you can see it when I put it right there. All right. And 4 drops of my diphenylamine indicator. Okay. So 1, 2, 3, and 4. Okay. Solution 1 ready to go. Swirl it all up. We're going to do a lot of swirling in this lab. Woo. All right, so let me note the starting point of my burette. So my V naught, my V initial, whichever you want to call it. V naught, V sub 0. That's what I like to call it sometimes. So V naught is 1.02 milliliters. So 1.02 interested in is the delta V for each portion here. We're going to look at the change in volume for each one of these. I'm going to put a white piece of paper behind my solution. It can help that color change be a little bit more obvious, especially possibly on camera. All right, I'm going to go ahead and zoom in and put my white paper up. Okay, so I've focused the camera in on the solution. You can't take reading measurements on burette anyway. There's no way I can make you see that on the camera. So let's focus on that color change. So I've taken my V naught, my initial volume of my zinc sulfate in the burette. Now I'm going to go ahead and start adding it and swirling so we can see color changes. And we're going to do multiples so we can kind of make a mess. So you guys see that little bit of a blue color change starting to happen in there? So we're definitely getting closer already to our endpoint. I want to take it slower as I get to that color change so I get my endpoint as close to that color change as possible, or stop adding zinc as soon as we get to that endpoint. We don't want to overshoot the endpoint. So I'm going to add just a little bit. I see some blue starting. It's turning a milky white color. You guys see that? Add just a little bit more because it is coming out quick. So I'm just going to slightly turn the stopcock to add drops. And I'm going to swirl. Swirl, 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 swirl. The entire solution changes color. So once we've gone through this first one, we'll definitely have an idea of how much zinc it takes to get to the end point of this reaction. Oops, that was a little bit too fast. It's taking too long, so I ramped it up a little. Add a little, it turns blue, swirl it, it goes away, so we have not reached the end point of the reaction yet. There we go, nice drip. Second drip, and I can swirl. Got a slow, steady drip of the zinc sulfate dripping into my iron mixture. Waiting to see a blue change. The blue is lingering longer and longer each time a drop hits. Swirling. Sometimes, if you have enough solution, you can do like a really quick titration and get a really rough estimate. So you can do a more accurate one next and save yourself some time, I guess. And get a rough estimate of the change of volume it takes to reach the end point of your reaction. I feel like I'm really close, so I'm going to tough it out. I'm not going to do that. So you can see the color of my solution changing. It was clear and yellow. It's definitely got like a milky yellow tinge. Every drop of the zinc sulfate that hits. There's a blue tone that lingers longer and longer. See, can you see them in there? They still go away when I swirl. I'm willing the end point to come. It's there. Gotta be. It's being super persistent now. Come on. Stop it for a sec. See that blue lingering in that swirl? We're not quite there, are we? All right, I definitely see a blue tinge across this entire solution. So what I'm gonna do is I'm gonna go ahead and note my current volume, and then I'm gonna add a little bit more. And if it's a stark color change after that, that means that I was at my end point. So we can note it and not overshoot it. So let's go ahead and see that we've got 19.01 milliliters. I'm just gonna note that for now. I'll write it down so I don't forget it. So 19.01 milliliters. This may or may not be our endpoint, but just in case it is, we're gonna write it down because we can't take it away, right? We can always add more, but we can't take it out. So I'll add a few more drops. Ooh, there we go. Look at that. Let's see how much more we added. So we had a huge color change. But I would say I'm going to change that endpoint volume to this one, because it did take quite a few more drops, just not a drop or two. Is my arm totally in the way the camera is? Okay. So we've got 19.5, 19.6, 19.73. final volume was 19.73 milliliters. My first titration. So that's titration 1. Final. Alright, so let's do titration 2. Maybe not. Maybe final. Now we're on the third titration. We're going to take an average of the 3. So there is titration 1. I'm going to go ahead and I'm going to refill my burette with my zinc sulfate solution because I don't want to get caught without enough zinc sulfate in there. So I'm going to go ahead and top it off because I'd be bummed if I ran out on the second titration. So we should get all 3 titrations in roughly the same, about 19.5 milliliters. I almost went over, but I didn't. I made it. Okay, I've got my 25 milliliters of potassium ferrocyanate that I pipetted earlier. Didn't want to do it more than once. I got it all done with. Let's put that there so you can see it. I'm going to add about 5 milliliters of 3 molar sulfuric acid. Put the lid on more. I'm going to add my other 2 ingredients. 3 drops of the 1% potassium ferric cyanide. 1, 2, 3. And 4 drops of my diethylamine indicator. 1, 2, 3, 4. Swirl it. And note my initial volume. So maybe not for test run number 2 is 0.16. So 0.16 milliliters is maybe not. So we're interested in the delta V for each one of these, our change in volume. So go ahead. I'm going to let it flow pretty good till we get down a ways. This one will hopefully go a little bit faster. We know approximately where that endpoint should be. Let it run and swirl. And get to about 17 milliliters. Okay, let's see, we're just over 15 milliliters. Yeah, able to add quite a few more before we see that big color change. All right, now we're really close. I'm just above 18, so I'm close at that 19, so I'm gonna go ahead and slow it down so I don't overshoot my endpoint because no fun repeating our work. And turn it on so it slowly drops. Come on. Come on. There we go. Drops coming out. I'm going to swirl and let it drop, all the while keeping an eye on my approximate volume and watching for that color change. Let's do that down. Stop, stop, it's turning purple. Oh yeah. Let's see. Got our color change there. And let's see, 18.5, 18.6, 18.7. I'm reading the meniscus and its little lines. 18.70. 18.70 milliliters. Calculator. I want to calculate my delta V's to see if they were close to one another, close enough to one another. I'm going to look at my delta V. Delta B's and see if they were close to one another, and then we're going to do our third run. Okay, let's do titration number 3. Both of sat for a second, kind of settled out. Move those over, and I'll add my other stuff and refill my zinc sulfate. Out 5 milliliters. Oop, that was way a lot more. I'll force them out of my waste container. That's not way a lot more than like 2 milliliters. Okay. On the counter. I'll go ahead and clean that up. Just gotta stick my elbow in it. That would have cool. Quite warm actually. All right, 5 milliliters, 3 drops of my ferric cyanide. 1, 2, 3. I don't know. I can do these all 2. Here we are. Indicator. 1, 2, 3, 4. Swirl it. Gotta make sure I refill my zinc sulfate so I don't very readily run out of my titrant. Note my B naught, my initial volume. My initial volume is 1 point, let's see, where am I at? It's 5, 6, totally, oh, not leaning in front of the camera, I thought it was. 5, 6, 7, 8, 1.80 milliliters is my B naught. Okay, let's get to titrating. Close. My endpoint, so I'm going to go ahead and slow down my flow to drops. there we go, there we go. I got my purple. Oh, shakalaka, nice pale purple. Good Lord, that was hard to say. All right, 20 point. 1, 2, 3, 20.3. 20.38. 20.38. Check my delta V. And let's go at 1.8. 18.58. Boom, that was a good one. 18.58. So my delta V's were 18.71 milliliters, 18.54 milliliters, and 18.58 milliliters. Boom, we're gonna call that good on those titrations. Nailed it. All right, so now that you have those concentrations, you can figure out moles, and then you can figure out mole ratios, and then you can figure out your proper coefficients, and pick which one of those equations is the actual equation that's happening here, and then use that to figure out, for part E, the concentration of your unknown. All right, part E, finding the concentration of the unknown ferrocyanide solution. So we have an unknown ferrocyanide solution that we are going to find the concentration of. So we still know the concentration of our titrant, of our zinc sulfate. That is the same solution we made before. So that is the same solution we're going to use to figure out the concentration of this sample. So we're using unknown B as our sample. So I'm going to go ahead through my pipetting procedure, do the exact same things we did for the previous section, only with an unknown. So let's get that one out of here. Actually, I'm going to go ahead and fill up my zinc sulfate so I have a moment to settle before I read the volume. All right, that's good. From the sample jar. I am going to pipette directly from the sample jar, and only because I'm the only one using it. Don't have to share it with nobody else. Nobody else is using it. It doesn't get touched again. I don't like doing dishes, so I don't want to do more glassware. How's that sound? No, it's a little lazy. It's okay. So I'm going to go ahead and do my pipetting procedure again. Use the bulb to suck this volume up into the pipette. Don't normally pipette directly from the sample container unless it's only yours. Then you can do what you want, contaminate it however you want. You mess up only yourself. Boop. All right, 25.00 milliliters even of my unknown. Going into sample container numero uno. Sample number 2. Move out of the way. I can totally see myself not putting the next aliquot into a Erlenmeyer flask that already has one in it. So I move it out of the way to make less room for silly errors. Okay. Sample number 3. Close my sample jar. Put it out of the way. All right. 3 bits of my unknown divvied up. Uno, dos, tres. All right, so this time I'm going to go ahead and just divvy up my sulfuric acid for all 3 of them from the get. I think it'll be fine. Speed this process up. All right, about 5 milliliters. Into sample number 1. Here. Sample number 2. Probably too much. Sample number 3. Okay. 1% potassium ferricyanide. 3 drops into each. 1, 2, 3. 1, 2, 3, and 1, 2, 3. Our phenylamine, diphenylamine indicator, 4 drops. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Boom. Done. All right. Swirl. And I'm going to note my initial volume of my zinc sulfate. Forget to do that. Oh, you'd be mad at that one too. That's starting over. So many places where you can start to go over if you don't pay attention to detail and this type stuff. Here, let's turn this so you're not staring at me. There you go. All right, 1 point. Let's call it 1.39 milliliters. My B naught for titration 1 and my unknown B. All right, so we don't know because it's an unknown concentration, so we have to go slow. With the addition of our zinc sulfate, you don't know exactly how long, what the concentration is, so we can't go through this too quickly, or we can zoom past our endpoint. Note we go through that milky color first before we get to that purple endpoint. definitely got like a pale color going on here. And that purple was starting to show up. Let's go ahead and note our current volume, and then we'll add a few more drops. So we're at 19.10. All right. So that endpoint is 19 point 19, I can't see it, hold on. 19.25. So 19.25 for that change, for that final volume. All right. Ooh, it's already ready to go. Let's go ahead and top off our zinc. So let's see, that took, without actually doing the math, it took about 18 milliliters. So we have a rough idea for our next go. Okay, here we go. 0 point. Milliliters. 0.20 milliliters for V naught. About 13 milliliters, got a little bit, good amount left to go. Let's see, we're at 17.7. Not quite yet, I added some more. Color changed back, it didn't stay. Why is it dripping? Alright, there we go. We definitely have our color change now. That is, let's say, 18 on the nose. 18.00 milliliters. Just a touch more to see that big purple color. There we go. I'm going to top off my zinc and do run number 3 for our unknown. Then I'm going to look at my delta B's and decide if we should do a fourth one or not. Too much zinc. much in. It's above the 0 mark. I'll let some out so I know what my initial volume is. There we go. V naught is 0.31 milliliters. 0.31 milliliters. Have a volume change of 19.8 milliliters. That last run was on money. We caught it just at that faintest bit of a color change. Here we go. Adding my zinc sulfate. My color change in there, turned off my drip. Just a drop in there. Can we do that? Just a little bit. The fainter the color change, the closer you are to that end point. All right, definitely have our color change there. Turned it a little farther than I wanted to, but hey, it happens. All right, so my endpoint this time is 18.18 Let me double check my delta V's and see if I want to do a third run. See if they're close to one another. Okay, my delta V's checked in at 17.86 milliliters. And for run 1, titration 2 was 17.80 milliliters, and titration 3 was 17.87 milliliters. Kind of nailed it. Pretty good. So I'm going to go ahead and call it